14.4 is about area and the law of sines. Now, we didn't get into law of sines and law of cosines last year, but you'll start to learn a little bit of here, and it's going to parlay itself into honors pre-calc as you move on. So what's the area of this? Now, you could do a couple different things. You could take C, and you could drop down the altitude, try to use Pythagorean theorem or whatever, but you don't using the 31 degrees and maybe whatever there to find that the height of the altitude. But why do that when they give you kind of formulas up here to do that? What is the area of triangle ABC to the nearest tenth of the square mile? So again, well, how does that work? Well, it's just 1/2 the two sides times the sine of the angle included. Okay, so since 31 degrees is between 10 and 5, that's the angle that's included. So it's 1/2, and they give you all this BC sine A or 1/2 AC sine B. All it really takes is the two sides and then the angle in between those two. So 1/2 of 5 times 10 times the sine of 31 degrees. Punch that in your calculator, and you get the area to be about 12.9. This is where they talk about the law of sines. And again, in a triangle, the ratio of a sine of each angle to its opposite side is constant, in particular for triangle ABC labeled as shown. What this helps you to do is to solve any kind of triangle that's not necessarily a right triangle. Obviously, you see these aren't right triangles. So we're going to do this by using this law of sines. And what you need is you need two angles. Well, you either need two angles or two sides to do this, to do law of sines. We'll talk about law of cosines later and what you need, but it kind of changes a little bit. So in triangle PQR, measurement of R is 39 degrees, Q is 32 degrees, and PQ is 40 centimeters. So they want to know what RQ is. They want to know what this is right here. The problem is you don't know what this angle is. Okay, you need the angle across from it. So 39 is across from that, so you'd be sine of 39 over 40 equals the sine of whatever that angle is over x. But we don't know what that angle is. Well, again, that's kind of the good news is that having taken geometry last year, we know there's 180 degrees in a triangle, so we just go from there. It's 180 minus 39 minus 32, which gives me 109 degrees. Okay, so I can use that as that point right there. So the sine of 109, that gives me those degrees, and that's over x. Okay, so again, how do you solve any proportion? Well, it's simply a matter of just cross multiplying. So you get x sine of 39 equals 40 times the sine of 109 divided by the sine of 39. This is all calculator stuff. Again, make sure it's in degrees, not radians, because you're dealing with degrees here. X is going to be roughly 60.1 centimeters. In triangle RST, T equals 7, R equals 9, and measurement angle R equals 110. What's the measurement angle S? So we're trying to find S, so I have marked as an X up there. So again, how do we do this? The problem is I don't have the side across from S, so I really can't solve for S right now. But remember, triangles have 180 degrees in them. It's kind of a nice little fact. So I could take the sine of T, okay, over 7 equals the sine of 110 over 9. Once I solve for T, I could just subtract them from 180 to get S. So you cross multiply, 9 times the sine of T equals 7 times the sine of 110. Divide by 9, I get the sine of T equal to 0.731. And again, to get rid of that, I have to inverse sine both sides. That's going to get rid of sine. I end up getting angle T equals about 47 degrees. So to find angle S then, you're going to take 180 minus 110 minus 47. And that's going to give me 23 degrees.